Hello students, today we're going to look at the next section in our textbook, which is 10.2, and it's graphing the functions y equals ax squared plus bx plus c. So we're adding that middle term, the bx, into what we're doing now, which is a little different from what we did in 10.1. So the first thing that I need you to do is to draw this little diagram in your composition book, and I'm going to talk you through it so you have time to do it as I'm explaining. The first thing I need you to do is to draw your x-axis and your y-axis, and make sure you label it as x-axis and y-axis. Then what I want you to do is to draw this dotted line, dotted vertical line, somewhere on the right-hand side of the origin. Doesn't matter where. And then you're now going to draw, put your vertex, which is this dot right here, and draw your parabola. And make sure your parabola crosses the y-axis in one point to the left, and then mirrors on the other side of the dotted line when you go to the right. And now we're going to label a couple of things. The first thing you're going to label where this parabola crosses the y-axis, that's labeled 0, c. C as in the c in the function. 0, c. And let's go back here to your vertex, and you're going to label that x equals negative b over 2a. Again, x equals negative b over 2a. That is how you find your vertex, but it's also the equation for this new thing we're going to call the axis of symmetry. The dotted line is called the axis of symmetry. Once you have that diagram, then we're going to explain some things from it. So I have a parabola. It's in the form of ax squared plus bx plus c. I have my axis of symmetry, that's a dotted line. My vertex, where I cross the y-axis at 0, c. And then I'm labeling the axis of symmetry. Now in all of the parabolas that we graphed yesterday, all of them started or had a vertex that was on the y-axis. Well, now that we've introduced ax squared plus bx plus c, that vertex is probably not going to end up on the y-axis. It's going to end up on what we call the axis of symmetry. And that's going to be something new that we're going to find. The axis of symmetry is the equation of the line that splits the parabola in half symmetrically, so each side is a reflection of the other. And the axis of symmetry is always found by finding x equals the negative of b over 2a. So whatever b is, take the opposite of it and put it over 2a, and that's going to be the equation of the line that is the axis of symmetry. Okay, so I'm going to write over here axis of symmetry. And that's the equation that we would use to find that. X equals the negative of b over 2a. Now, to find the vertex, I would take whatever x equals, plug that into the equation to find y, and that gives me my vertex. So it's x comma y, and this x comes from here. And then I plug that into the equation to find y, and that gives me my vertex. I know I'm doing a really bad job of not being in the video and covering up stuff, so I may stand to the side. So the important thing to remember, you need to know this. These are things that you just have to have memorized. The equation for axis of symmetry is x equals the negative of b over 2a, and the vertex is found by taking that x that you found and plugging it into the function to find out what y equals, and that will be your vertex. The other thing to notice is the y-intercept. You've probably figured out that the y-intercept is the place where the parabola crosses the y-axis, but we can find that with the point 0, c. So whatever c is in my function, 0, c is the place where your parabola is going to cross the y-axis, which would be our y-intercept. In just a second, we're going to look at a sample problem with a real equation, and we'll figure out all of this information. So here's the problem that we're going to use as an example. It's y equals negative x squared plus 4x minus 1. Now I have my simple coordinate plane here. I've got my x-axis and my y-axis. Notice that my y-axis is pretty far off center for a purpose, and you'll see what that purpose is in just a second. We're going to look at 6 different things from this equation. First of all, number 1, we know that this opens downward because A is negative. So we know that this is going to open downward. Now the second thing that we're going to look at and pay attention to is we need to find the axis of symmetry. So number 2, our axis of symmetry is going to be x equals the negative of b over 2a. b in this case is 4, so it is negative 4 over 2 times negative 1, which equals negative 4 over negative 2, which equals positive 2. So the equation is x equals 2. So I'm going to go ahead and draw that. I'm going to go over here to 2. I'm going to just assume that this is 2 by right here, and I'm going to draw a dotted line down x equals 2. And that is my axis of symmetry. So I know that my vertex is going to be somewhere on that axis, and that's going to split my parabola in half. The third thing that we need to find now is my actual vertex. So I'm going to plug in 2 for x, so I have y equals the negative of 2 squared plus 4 times 2 minus 1. So I have y equals negative 4 plus 8 minus 1. And that equals 4 minus 1 is 3. Y equals 3. So my vertex is, and let me fix the camera just a little bit. So my vertex in this case would be it will be 2, 3. Because x is 2, I plugged it in and got y, so y is 3. So I'm going to go over 2 and go down 3, and we're going to assume that's 2, 3, which is my vertex. I bet you're wondering to yourself, Mr. Cohens, you made a mistake in the last part, and you need to fix that. You're exactly right. I plotted the vertex in the wrong place, because the vertex is 2, 3, and I did 2, negative 3. So let's fix that. So the vertex should be 2, 1, 2, 3. We'll guess that right there is about 3. So that's 2, 3, and that's my vertex. Apologize for all that. Everything else is still okay. And now we're going to move on to number 4. I didn't have room to write number 4, so we're going to just keep going with number 4. The next thing we need to do is plot 2 points on the graph. Okay, or the rest of the points. I'm only going to choose 2 of them because you're going to see that I can use my axis of symmetry to plot some more points on the other side. So right now I'm going to choose 0 and 1 for x, and then find out what y equals. So when I plug 0 into my equation, I get negative 1, because 0 plus 0 is 0 minus 1 is negative 1. When I plug 1 in, I get negative 1 plus 4 is 3 minus 1 is 2. So there are my other 2 points. 0, negative 1, and 1, 2. 2 is going to be about right there. So there are my 2 points. Now I can use my axis of symmetry, because we know what symmetry is, to plot 2 more points. And I know there's one going to be right here, and my other point is going to be right there, because they're the same distance from the y-axis. So I draw my smooth curve, and there we go. And that is the graph of my parabola. And the next thing, that was number 5. Reflect the points. And I just reflected them across my axis of symmetry. So I could create a table with all those points in it, but I don't have to, because I can let the axis of symmetry help me dictate what's going on there. And number 6 was to draw the parabola, which we have done. So once again, you first have to have the equation of the line of symmetry, use that to find your vertex, and then plot 2 more points, use the line of symmetry to plot 2 more points, and then your parabola is all finished. So that is all of the basics of graphing a function in the form of ax²+bx+c. What I'd like for you to do is just take a picture of your notes page and submit that, and that will be your practice problem for this video. And in class for the next couple of days, we'll be doing a lot of these together.